In this section, we're going to be looking at characteristics of quadratic function. To start off with, we're going to look at 0 of a function. A 0 of a function is an x value that makes the function equal to 0. So basically, whatever x value produces a 0 for y. So we're going to look at the example we have here. We have the equation y equals x squared minus x minus 2, and you can see the graph of this equation. Now, we want to find the zeros of this function based from the graph. So we can see that the graph crosses the x-axis at -1 and 2. So the zeros appear to be -1 and 2 because those coordinate points would be 2, 0 and -1, 0. So all we need is the x values. So the zeros would be -1 and 2. Now we're going to look at the axis of symmetry. A vertical line that divides a parabola into two symmetrical halves is the axis of symmetry. So we're going to look at the axis of symmetry for a graph that only has 1, 0. So basically a graph that's touching the x-axis with its vertex means that it only has 1, 0. So if a function has 1, 0, use the x-coordinate of the vertex to find the axis of symmetry. So here we can see that the coordinate for the vertex is 3, 0. So the axis of symmetry would be x equals 3. That's the point where it divides the graph exactly in half. Now we're going to look at an example of finding the axis of symmetry when there are two zeros. If a function has two zeros, use the average of the 2 points, 2 zeros, to find the axis of symmetry. So for example, we're going to draw a graph, and we can see that we have two zeros, one at 0, 4 and the other at 0, 0. So I mean 4, 0 and 0, 0. -4, 0 and 0, 0. So in order to find the axis of symmetry, you want to add both the x values. So we got -4 plus 0 divided by 2. When we simplify this, we get -4 over 2, which simplifies to be -2. So the axis of symmetry is x equals -2. And when we go to the graph and plot this line as a dotted line, we can see that this line does indeed split the graph in half. So it is the axis of symmetry. Now we're going to look at finding the axis of symmetry by using a formula. So let's rewrite the quadratic function formula. Y equals ax squared plus bx plus c. And we know the axis of symmetry is a vertical line, so x equals -b divided by 2a. This is the formula we're going to use in order to find the axis of symmetry. So let's look at an example. We have the equation y equals 2x squared plus 4x plus 5. So we can just plug in the information into our equation. So we got x equals -b. And we can see that b right now equals 4. So -b would be -4. And then we have 2a. So basically 2 times a. And in this case, a is 2. So 2 times 2. And that leaves us with -4 over 4. And when we simplify that, we get x equals -1, which is the axis of symmetry. Now we're going to do an example of finding the vertex of a parabola. Here they've given us the equation y equals -x squared minus 2x. And they've also given us a graph. So we want to start off by finding the x coordinate. Based on the graph, we can see that the zeros are -2 and 0. Because that is where the graph crosses the x-axis. So again, we want to find the line of symmetry because that gives us the x value of the vertex. So we do -2 plus 0 divided by 2 equals -2 over 2, which would simplify to -1. And this is, so if we draw a line for x equals -1, we would have the axis of symmetry. and that gives us the x value of the vertex, which is what we're looking for. So we can now plug in that x value into the original equation, which is y equals negative x squared minus 2x. And once we plug it into the equation, we can see that y equals negative 1 squared minus 2 times negative 1 equals 1. So the coordinate, or the ordered pair, of the vertex of the parabola is negative 1, 1.